Okay, so in this video, we're going to talk about the law of conservation of momentum, and also we're going to discuss elastic collisions. Now, by now, you should know the difference between an elastic collision and an inelastic collision. Elastic means that objects do not stick together, therefore the momentum, their velocities are different after they collide. And inelastic collisions, when they collide, they stick together, and the final velocity of the objects is the same. Now, this is the handout that you should have and follow along with, the guided notes. Now, the law of conservation of momentum says that the total momentum of the objects in a closed system is constant. It says that the momentum before collision equals the momentum after a collision. A closed system is a group of objects not acted upon by any external force. Newton's third law states that every force has an equal and opposite reaction force. Therefore, if one object acts on another object for a specific amount of time, both objects will experience the same amount of impulse but in opposite directions. Therefore, P before equals P after. That's momentum before the collision equals the momentum after the collision. All conservation momentum problems that we deal with in this class will be two objects either colliding or exploding. Since the closed system involves both objects, we must add the momentum of each object in order to describe the total momentum before and or after the collision or explosion. All right, so if we look at a little simulation of this, two objects are collide, they have an initial momentum. And after they collide, if you add the initial momentum of both objects before the collision and then the momentum of both objects after the collision, they should equal. So another simulation here. If you notice, they both have an initial, like the green box has a mass of 2 kilograms. It's moving to the right. If something moves to the right, it has a positive velocity. If something moves to the left, it has a negative velocity, and that's very important working these problems. If you don't show that, you'll get the problems wrong. And they have initial momentum. If you notice, the green object is going to move to the right, so it's going to have a positive velocity. But then when it moves off to the left after collision, it has a negative velocity. And then the gray box there, it stopped instead of moving. So its final momentum would have been 0, but when you add it to the final momentum of the green box, it would equal the initial momentums of both added together. And just some other examples. These are all elastic collisions. So, to look at a first example problem, it says David hops in his 600 kilogram dune buggy and travels 20 meters per second to the east. Meanwhile, Sarah drives her 500 kilogram dune buggy at 30 meters per second east and tries to catch David. Remember, if we're moving east, that is positive velocities. If we're moving west, that is negative velocities. So, this problem, it asks, what is David's momentum? Well, David has a mass. Remember, momentum is equal to mass times velocity. So, he has a 600 kilogram dune buggy and it travels at 20 meters per second. So David's momentum, is P equals M times V. His momentum would be 600 times 20, which would equal 12,000. And then our units for momentum, if you remember, is kilograms times meters per second. And it asks, what is Sarah's momentum? Sarah, again, is P equals M times V. Her mass was 500 kilograms at 30. So it would be 500 times 30, which would equal 15,000 kilograms times meters per second. It says, what's the total momentum of the entire system? And as like I said, they haven't collided or anything. We would add those two together. because your momentum, your initial momentum of two objects we would add together. So that would have been 12,000 plus 15,000, which would give us 27,000 kilograms times meters per second. Then ask, if Sarah were to catch up to David and collide with his buggy, what would be the momentum of the system after the collision? Remember, your initial momentum is equal to your final momentum, and that's for both objects. If we had a first object, that would be P1 and its initial momentum plus P2's initial momentum would equal P1's final momentum plus the momentum of the second object is final. But it would be the same. That's the initial momentum of both of them added together, so the final momentum would equal 27,000 kilograms times meters per second. Okay, next we're going to talk about elastic collisions, and this video is going to be these problems we're going to work are dealing with elastic collisions. In elastic collisions, objects collide and move off with different momentums and different final velocities. The objects do not stick together. To do these problems in one step, we simply substitute the appropriate variables for the conservation of momentum equation. P before equals P after, which will give you, if we had P1 in our equation, this is going to be our equation you're going to need to be using to work for elastic collisions. It'll be a little bit different. We'll modify this equation when we work problems for inelastic collisions tomorrow. But, if we have, this is the momentum, the P1 initial of the first object, the momentum of the second object, its initial momentum, equals the momentum, P of the first object, the final momentum of it, plus the final momentum of the second object. And remember, momentum is mass times velocity. That's why we end up with this equation here. You have M1 V1I plus M2 V2I equals M1 V1F plus M2 V2F. Now these problems are not hard, they're just kind of long. We got a big equation here and you have to keep up with what's what. And what do these things stand for? Well, M1 is the mass of the first object. M2 is the mass of the second object. V1I is the initial velocity of the first object. Now, if it says that something's at rest, we know that the velocity is 0. Initial velocity, if something comes to a stop, we know that its final velocity is equal to 0. The V2I is the initial velocity of the second object. V1F is the final velocity of the first object. And V2F is the final velocity of the second object. Now, note there are two objects in the above equation, object A and object B. What we're saying though is object, you want to change that, object 1 and object 2. The left side is before the collision, and the right side is after the collision, the final velocities. So if we look at an example problem, and we're going to work these, using the guess method. We write our givens down, our unknown, our equation, and then we substitute and solve. So the best thing I would do is, a lot of times you can draw a diagram if it helps you to keep up with all these numbers. And it says that a billiard ball with a mass of 0.616 kilograms, what I would do is label these objects, label this first mass here, I would label it first mass, and it's moving at 30 meters per second, and strikes another 0.16 kilogram billiard ball. I will label this as the second mass. Label it as M2. The first one is M1. And a ball at rest. After the collision, the first ball continues moving at 16 meters per second. Determine the velocity of the second ball. So you can draw a diagram if it helps you. We have a, before the collision, we have a billiard ball. It has a mass of 0.16 kilograms. And it says moving at 30 meters per second. So we can label this initial, and it is moving at 30 meters per second, and it strikes another ball. So before the collision, this is M2, and it is 0.16 kilograms. And it's at rest, so it is moving at 0 meters per second. Now after the collision, we have the billiard ball here. It has a mass of the first one with 0.6 kilograms. And it says, after the collision, the first ball continues moving at 16 meters per second. Now it doesn't tell you it's moving to the left. It says it continues moving. If it doesn't give you a direction to the left or west, consider it to be positive. Consider it like it's still moving to the right. So that would be 16 meters per second. So in this case, and the other ball, 0.16 kilograms, and it says continue it. We don't know what its velocity is. That's what we're looking for. So if we write our unknowns and our givens down, if we write these down, all right, we have M1 is equal to 0.16 kilograms. And then V1I, its initial velocity we said was 30 meters per second. We have M2, which is 0.16 kilograms also. And its in V2I, its initial velocity is 0. And then we don't have to write M1, M2. We have V1F, the final velocity of the second one is 16 meters per second. And the V2F is what we're looking for. Now we're going to write our equation down. We'll separate all this. And our equation is M1 V1I plus M2 V2I equals M1 V1F plus M2 V2F. And we're going to substitute our values and solve. Now we can shorten up this equation. Remember, V2I equals 0. So that's going to make this whole thing equal 0. So we can do away with that when we plug in our numbers. So now start plugging in our numbers. We have M1 is 0.16 times V1I, which is 30, equals, since that equals 0, we're going to do that. M1 again is 0.16 times its final velocity, V1F, which is 16, plus M2, its mass was 0.16. And then our unknown here is V2F. That's what we're going to be solving for. Now I want to clean this up a little bit, make it a little bit easier to solve. Bring up my calculator. I'll take 0.16 times 30 equals 4.8. Equals 0.16 times 16 is 2.56 plus 0.16 times V2F. Now I subtract both sides by 2.56 equals 0. That's 2.56. 4.8 minus 2.56 equals 2.24 equals 0.16 times V2F. Going to divide both sides by 0.16. That'll give me my answer, 2.24 divided by 0.16. And my final velocity, V2F, equals 14, and it's meters per second, would be my answer. These problems are kind of long. You need to really keep up with your signs of your velocities. But it's like working all the other problems. You just, plug in your numbers and substitute and solve. So if we look at another example, number 3, a 4,000 kilogram pickup truck traveling at 40 meters per second collides with a parked car. After collision, if the pickup truck continues moving at 15 meters per second and the car moves at 50 meters per second, determine the mass of the car. And like I said, if it doesn't give you directions in the problem, we're going to assume that they're moving east or to the right, unless it tells us specifically that they're not. So in this problem, I want to label what's going to be M1, M2. So for the 4,000 kilogram pickup truck, I'm going to call that my first object. So that's M1. It's traveling at 40 meters per second. That's going to be its initial velocity. So if this pickup truck, and before the collision, and I can't draw, I'm just going to sketch here. This truck, it's got a mass of 4,000 kilograms, and this is initially it's moving at 40 meters per second. And it collides with a parked car. Now, I don't know what this car is. This parked car, I don't know what its mass is. So that's my question mark, and it's parked, so it has a initial velocity of 0 meters per second. That's before the collision. After the collision, this still is a 4,000 kilogram first object. After the collision, the pickup truck continues moving at 15 meters per second, so its velocity is 15 meters per second. And the car moves again, I don't know its mass, and the car moves at 50 meters per second after collision. I want to determine the mass. Alright, so now I'm going to write down my givens and my unknown. So I know that M1 said was 4,000 kilograms. V1I is equal to 40 meters per second. My second object, I don't know what it is, what I'm looking for, but I know that V2I, its initial velocity is 0. And then V1F, my final velocity of the first object, moves off at 15 meters per second. And then V2F is 50 meters per second. It's speed. It helps to draw these out. It's not necessary if you can work these problems, but it really helps to draw them out to keep everything in front of you where you can tell what you're doing. Now my equation is M1 V1I plus M2 V2I equals M1 V1F plus M2 V2F. And then I'm going to, again, V2I is equal to 0, so that's going to make this whole thing equal 0. I can do away with that. So M1 is 4,000 times V1I, which is 40, equals M1, which is, again, is 4,000 times V1F. V1F is 15. Plus M2 is what I'm looking for. So I'm going to leave it as M2 and said V2F was 50. So I'll get my calculator. $4,000 times 40 equals 160,000. Equals 4,000 times 15 equals 60,000 plus, and then M2 times 50. So I'm going to move and subtract both sides by 60,000. That will give me 100,000 equals M2 times 50. I want to solve for M2, so I'm going to divide both sides by 50. So 100,000 divided by 50 equals 2,000. So M2, my mass, is 2,000. The units for mass are kilograms. That would be my answer. Okay, next problem. A 3,000 kilogram truck traveling to the right at 20 meters per second collides with a 1,000 kilogram car traveling to the left at 5 meters per second. After the collision, the car moves to the right at 10 meters per second. Find the velocity of the truck after the collision. Again, if we want to draw this, I'm just going to use a box for my first object. And we're saying M1 is 3,000 kilograms. And it's traveling to the right at 20 meters per second, so its velocity is positive 20 meters per second as it's moving this way. And it collides with a 1,000 kilogram car traveling to the left. So we have a car Traveling to the left, it is 1,000 kilograms. If it's traveling to the left at 5 meters per second, that's going to be negative 5 meters per second. That's my initial conditions. Afterwards, my first object here, the car, it says the car moves to the right. And remember, the truck was my first velocity, so the car, car moves to the right, so it's going to be, after the collision, it's going to move this way. Remember, it weighs 1,000 kilograms. And if it moves to the right, it's going to be at 10 meters per second. The second, the first object, the truck, was 3,000 kilograms. And we want to find it. So we're looking for V1F. So when I write down my unknowns and my givens, M1 equals 3,000 kilograms. V1I equals 20 meters per second. M2 equals 1,000 kilograms. V2I, its initial velocity is negative 5 meters per second. And then V1F is my unknown, what I'm looking for. And V2F is positive 10 meters per second. So my equation, right, is M1 V1I plus M2 V2I equals M1 V1F plus M2 V2F. Alright, so I'm going to substitute and solve. My first initial velocity is 3,000 times V1I, which is 20, plus M2, which is 1,000, times V2I, which is negative 5. M1 is 3,000 times V1F, which is my unknown, plus M2 is 1,000 times V2F, which is 10, positive 10. Now, when I clean this up, 3,000 times 20 is going to equal 60,000. And then plus 1,000 times negative 5 is going to be negative 5,000. So I can just put minus 5,000 equals 3,000 times V1F plus 1,000 times 10, which would be 10,000. Now, when I kind of clean this up, 60,000 minus 5,000, it's going to be 55,000 equals, and I can go ahead actually, 55,000, and then I'm going to have to subtract 10,000 from that. So that's going to be 60,000 minus 5,000 would equal 55,000, and then when I move the 10,000 over, it's going to be 45,000 equals 3,000 V1F. If I divide then both sides by 3,000, my answer, V1F, final velocity of the first object, $45,000 divided by 3,000 equals 15. So it would be positive 15 meters per second. Now, if we look at our last problem here, I'm going to help you get it set up, and then I'm going to let you solve it on your own. Tom's 100 kilogram bumper car is traveling east at 10 meters per second when it collides head on with Ray's 80 kilogram bumper car traveling west. After the collision, Tom's car travels west at 20 meters per second, while Ray's travels east at 15 meters per second. Determine Ray's initial velocity. So we're saying that first, his bumper car, the first one, the bumper car is Tom's, and it is 100 kilograms, and it's traveling east, so it's traveling this way, and it collides head on with Ray's bumper car. That's going to be my M2, and it said this first object traveling east at 10 meters per second, so that'd be positive. And then Ray's collides head on with Ray's 80 kilogram bumper car traveling west. So we know it's traveling west, but it doesn't give us that velocity. That's our unknown. After the collision, it says Tom's car, which is 100 kilograms, travels west at 20 meters per second, so that would be negative 20 meters per second. So it's going to be traveling this way after it collides. And then Ray car is 80 kilograms, and it travels east at 15 meters per second, so that'd be positive. And we want to determine Ray's initial velocity. So we're looking for Ray's was the second object, so we're looking for V2I. So we know that M1 is Tom's car, it's 100 kilograms. So V1I is 10 meters per second. The second object is 80 kilograms. We're looking for V2I. That's our question mark. And then V1F, the final velocity of the first object is negative 20 meters per second. And then V2F, the final velocity of the second object is 15 meters per second. Now, start with your equation and then substitute and solve. I'm going to let you solve this problem and come up with the answer. And after you come up with the answer, check it with your classmates. And then after that, we have a worksheet to do on these types of problems. If you do not finish the worksheet in class, you'll have a little bit of time tomorrow to finish that.